So what if a computer could solve a problem in just a few minutes that would take even our fastest supercomputer thousands of years to figure out? Sounds like something straight out of science fiction, right? Well, it's not. It's the revolutionary promise of a totally new kind of computing.
Yeah, we're talking about quantum computing. And over the next few minutes, we're going to break down the absolutely mind-bending ideas that make it work and the world-changing problems it's getting ready to solve.
All right, first things first, let's talk about the quantum promise. To really get what's going on here, we have to start with the absolute fundamentals, and that means understanding the difference between bits and qubits.
Okay, let's dive right into this, because this is the core of everything. Every single computer you've ever used, your laptop, your phone, it all runs on bits. Just think of a bit like a simple light switch. It can either be off, which is a 0, or on, a 1. That's it. But a quantum qubit? That is a whole different animal. It can be a 0, it can be a 1, or, and this is where it gets weird, it can be both at the exact same time. And this is all possible because of two very strange rules of the quantum world.
The first of these rules is called superposition. The best way to picture it is to think of a spinning coin. While it's in the air, flipping over and over, is it heads or tails? In a way, it's both. It only actually picks a side when it hits the table and you look at it. A qubit in superposition is just like that spinning coin. It holds the possibility of being both 0 and 1 until the very moment we measure it. And then there's the other piece of the puzzle, entanglement. This is the one Albert Einstein famously called spooky action at a distance. Imagine you have two of those spinning coins again, but this time they're magically linked. The instant one of them lands on heads, you know, without even looking, you just know that the other one, even if it's on the other side of the galaxy, has landed on tails. That's what entanglement does. It creates this unbreakable, instantaneous link between qubits.
So here's the really crucial part. You combine that superposition idea with entanglement, and you get something incredible. You see, a normal computer trying to solve a tough problem is like one person in a giant maze. They have to try each path one by one. But a quantum computer, it's like having millions of versions of yourself exploring every single possible path in that maze, all at the exact same time. It's not just faster, it's a fundamentally more powerful way of processing information.
So what can you actually do with all this incredible power? Well, that brings us right to our next section, solving impossible problems.
Now, let's be really clear about something. A quantum computer is not going to replace your laptop for checking email or watching videos. This isn't about building a better gaming PC. Think of it as a highly specialized tool designed for a very specific class of problems, the kind that are so monstrously complex that they would completely break any normal computer we could ever hope to build.
And this is where it gets so exciting. We're talking about the potential to crack encryption that we consider unbreakable right now, the stuff that protects all our sensitive data. We're talking about designing new, life-saving drugs by perfectly simulating how molecules actually behave, a task that's just impossible today. Imagine figuring out the single most efficient route for every package in a global shipping network to eliminate waste, or designing a traffic system for a huge city that just ends gridlock. These are the kinds of world-changing problems quantum computing is built for.
But hey, if it was easy, we'd have it already. The biggest challenge is that qubits are unbelievably fragile. I mean, think of a quantum calculation as a delicate soap bubble. The tiniest vibration, the slightest change in temperature, and pop, the whole thing just vanishes. This is why these machines have to be kept in environments colder than deep space, and it's why they are so prone to making errors.
And because of those huge challenges, this is where we are today. This groundbreaking technology is basically living inside advanced research labs and in really experimental settings. We are still at the very dawn of this quantum revolution.
So where do we go from here? Let's take a look into the future, at the coming quantum world. So the path forward is a gradual one. Today, we're deep in that experimental phase. But over the next couple of decades, the expectation is that we'll start to see these quantum machines begin to tackle some of those huge, real-world problems. And they won't work alone. They'll work in partnership with our regular computers, creating a kind of hybrid system where each machine does what it does best. And even if you never personally log on to a quantum computer, its impact will absolutely reshape your world. It could revolutionize medicine by helping create personalized drugs designed molecule by molecule for your body. It could make our cities smarter with perfectly efficient energy grids and transportation. It will most certainly change the entire nature of digital security. This is the kind of technology that's going to supercharge scientific discovery and transform our society in ways we're only just starting to wrap our heads around.
When you step back, you realize this isn't just a new kind of gadget. As one expert put it, and I think this is perfect, quantum computing is not just a technological upgrade. It's a fundamental shift in how we process information. It's almost like we're learning a completely new language to describe and interact with the universe itself.
So, as we stand here on the brink of this incredible new era, the real question isn't if this technology is going to change our world, it's how. As this amazing power moves from theory into reality, how do you think this fundamental shift is going to reshape your world?